Hello. In today's webinar, we are going to talk about introduction to robotics with a focus on robotics in healthcare. My name is Eva Porculescu and I'm working as a robotics lecturer as well as R&D. What is robotics? Robotics is a field dedicated to creating machines that can perform specific tasks, ranging from simple to complex, with the goal of taking over labor-intensive and hazardous responsibilities traditionally performed by humans. These machines, known as robots, are designed to enhance productivity, streamline operations, and reduce risk in various industries. Robotics combines disciplines such as computer science, mechanical engineering, and electrical engineering, focusing on constructing robust mechanical systems, integrating advanced sensors, and implementing effective control mechanisms. It also utilizes artificial intelligence to enable human robot interactions. The field of robotics encompasses two main areas: the development of automated robots and the creation of intelligent or smart robots capable of making decisions while performing tasks. Robots offer numerous advantages, particularly in situations where human lives are at risk or tasks require precision and substantial force. By programming robots, repetitive and monotonous operations can be flawlessly executed with a level of accuracy rarely attainable by humans. Overall, robotics plays a crucial role in shaping the future of work and safety, offering versatile and adaptable systems that excel in tasks where human anatomy has limitations. There are three laws of robotics, and they were conceived by Isaac Asimov. These laws are as follows. The first law says a robot may not harm a human being or, through inaction, allow a human being to come harm. This law prioritizes the safety and well being of humans above all else. The second law states a robot must obey the orders given to it by human beings, except where such orders would conflict with the first law. This law establishes the importance of following human commands unless doing so would cause harm to a human. The third law says a robot must protect its own existence as long as such protection does not conflict with first or second law. This law acknowledges the value of self-preservation in robots, but places it below the imperative of ensuring human safety. What are the main components of a robot? Robots come in all shapes and sizes, all of which require different parts for construction. These are the three general categories of robotics. Computation. While saying a robot has a brain does a disservice to what we have in our own heads. They do have a central processing unit called a controller that determines the actions they take in a given situation. These controllers can be programmed to complete tasks as simple as turning a screw or as complex as emulating human social graces and expressions. Now we have movement. As autonomous units, robots need specific mechanical parts to allow them to move freely without direct physical intervention from their human operators. These parts include things like wheels that allow them to travel and motors that propel them. Other components, such as grippers, allow them to interface with the world around them in a direct and targeted way. The last ones are sensors. Sensors are what allow robots to recognize their surroundings. They give them the ability to determine things like the size and shape of an object or detect that there is heat, cold, or other properties. These capabilities allow the processors to collect data around the surroundings and the environment, then move accordingly. The robot types. Robots are intelligence tools capable of replicating human actions and replacing the need for human interventions. They are used for various applications, from manufacturing processes to hazardous duties like bomb disposal. Robots can operate in inaccessible locations, such as underwater or outer space, and handle tasks that contribute to environmental well-being, such as waste disposal. The field of robotics involves designing and building robots, as well as developing the computer systems that control them. Robots interact with the physical world through sensors, actuators, and information processing mechanisms. Industrial robotics, particularly in the context of Industry 4.0, is a significant application area for robots. Overall, robotics contribute to a more convenient and improved existence by performing tasks that are undesirable or unsafe for humans. It is a specialized field that encompasses engineering. Here are some common categories of robots. We have industrial robotics, service robotics, medical robotics, military, space, educational, agricultural, search and rescue robotics, underwater, and autonomous vehicles. First of them is the industrial robots. Industrial robots are used in manufacturing and industrial settings to perform repetitive tasks with precision and efficiency. They are commonly found in assembly lines, welding, painting, and material handling. These robots are programmable devices equipped with a robotic arm, gripper, sensors, and a control unit. They are designed to handle, assemble, or process workpieces autonomously. The global utilization of industrial robots has been steadily increasing, with approximately 290,000 units in use as of 2016. This trend is expected to continue, with an average annual growth rate of 12% in the coming years. Industrial robots have significantly improved workflow efficiency, safety, speed, and flexibility in the automotive industry and other industrial sectors. Their use continues to evolve, contributing to advancements in manufacturing and processes. Next is service robots. They are designed to assist humans in various non-industrial tasks. They can be further classified into several subcategories. Service robots are used in domestic and personal settings, such as vacuuming robots and personal assistants. They are designed to assist people with everyday tasks, such as cleaning, cooking, and providing information. They are also used in healthcare and elderly care facilities to assist with tasks such as lifting and moving patients. Domestic robots. These robots are used in homes for tasks like cleaning and mowing lawns or performing household chores. We have also healthcare robots. These robots are used in medical settings, including surgical robots for assisting in surgical procedures or robotic prosthetics for assisting with mobility. Education and research robots. They are used in education institutions or research labs to facilitate learning, experimentation, or data collection. Educational robots are used to teach programming and engineering principles to students. They are designed to be simple and easy to use and are used in schools and universities to introduce students to the concepts of robotics and programming. The hospitality robots, they are deployed in hotels, restaurants, or other hospitality establishments to provide services like reception, room service, or concierge assistance. The medical robots. These robots are specifically designed for medical applications, such as surgical robots used in minimally invasive procedures, rehabilitation, robots for physical therapy, or assistive robots for elderly or disabled individuals. Medical robots are used in surgeries and other medical procedures. They are designed to assist surgeons in performing complex procedures with increased precision and accuracy. They are also used in rehabilitation, physical therapy, and other medical applications. Robots designed for exploring and investigating environments that are difficult or dangerous for humans are called exploration robots. Examples include planetary rovers used in space exploration or underwater robots for deep sea exploration. Space robots are used in space exploration and satellite maintenance. They are designed to operate in these harsh conditions of space and are used to repair and maintain satellites, explore other planets, and perform other tasks. Research and rescue robots are used in natural disasters for search and rescue operations. They are designed to operate in extreme conditions and are used to locate and rescue victims of natural disasters. They also can be used for surveying and mapping the affected area and providing real-time information to the rescue team. The agricultural robots. These are the robots used in agricultural practices to automate tasks such as planting, harvesting, or crop monitoring. They can also include milking robots for dairy farms or autonomous drones for crop monitoring. We have food sorting in this category. In the rice industry, Robots play a crucial role in sorting and ensuring the quality of each grain. After harvest, a robot is responsible for individually examining and sorting the rice grains. Using advanced cameras and high precision, these sorting robots can process hundreds of grains per second. They determine if a grain needs any corrective treatment, such as color enhancement, before packaging. The robot's speed and accuracy guarantee consistent and reliable quality control, resulting in visually appealing and uniform rice grains for consumers. The autonomous vehicles, or AGV, are self-propelled transport vehicles that operate without human intervention and are guided automatically, including self-driving cars, trucks, and drones. They operate without human intervention by using sensors and artificial intelligence and navigation systems. They aim to enhance safety, reduce costs, and improve efficiency in transportation across various industries, such as agriculture and logistics. AGVs are commonly used in production facilities and warehouses for material transportations. They can have different power supplies, perform different tasks, and use navigation methods. The social and entertainment robots. These robots are designed to interact with humans in social or entertainment settings. They can be used as companions for the elderly, toys for children, or performers in entertainment venues. These categories are not exclusive and they often overlap between them as robotics technology continues to advance and new application emerges. We have robotics applications now. Robots have a wide range of applications across various industries and fields. Here are some common robot applications. Robots are extensively used in manufacturing industries for tasks like assembly, welding, painting, material handling, and quality control. They improve productivity, precision, and efficiency in production processes. Robots have become integral to the efficient processing and delivery of online orders, especially for platforms like Amazon that handle a high volume of orders daily. These robots are deployed in warehouses and play a crucial role in receiving, organizing, and retrieving products for dispatch. Incorporating robotic technology has become essential for retailers to keep pace with market demands and ensure efficient order fulfillment. Packaging and logistics. Robots are employed in packaging and logistic operations to sort, pack, palletize, and transport goods. They can work in warehouses, distribution centers, and fulfillment centers, streamlining operations and reducing manual labor. Healthcare and medicine. Robots are playing an increasingly important role in healthcare, assisting with surgeries, rehabilitation, diagnostics, and patient care. Surgical robots enable precise and minimally invasive procedures, while rehabilitation robots aid in physical therapy for patients with mobility limitations. In healthcare settings, robots can also assist with monitoring vital signs and administering medication. The integration of robust technology in healthcare and remote disease diagnostic is on the rise, but ethical consideration and accuracy are essential factors to address. Hazardous environments. Robots are crucial in hazardous environments where human safety is at risk, such as nuclear power plants, chemical facilities, and disaster sites. They can perform tasks such as inspection, maintenance, and cleanup, ensuring the safety of humans. In environmental cleanup efforts, robots play a vital role in areas contaminated with toxic waste, contributing to remediation. We also have a diverse applications in environmental initiatives, including recycling, tree planting, renewable energy harvesting, water pollution control, and invasive species eradication. Education and research. Robots are widely used in educational institutions and research labs to support learning, experimentation, and data collection. They help students grasp programming, robotics, and engineering concepts while assisting scientists in conducting experiments and gathering data. Robotics has become prevalent in children's lives, with many toys incorporating robotics features. The importance of robotics education lies in its ability to foster critical thinking, problem solving skills, creativity, innovation, collaboration, and teamwork among students. It encourages students to analyze problems, think critically, and develop innovative solutions. Robotics also promotes creativity by allowing students to design, build, and program their own robots, cultivating unique problem solving skills. Collaborative projects in robotics develop effective communication and teamwork skills. Furthermore, robotics education aligns with STEM initiatives and competitions that inspire students to explore robotics and pursue careers in science, technology, engineering, and mathematics. Robotics clubs, competitions like FIRST Robotics and VEX Robotics provide hands-on learning experiences and foster technical proficiency, creativity, and innovation. Entertainment and hospitality. Social robots are used in entertainment venues, hotels, and theme parks to interact with guests, provide information, and entertain visitors. They can serve as companions, perform shows, or offer personalized service. At Munich Airport in Germany, Josie Pepper, a humanoid robot, is aiding passengers with her roller-based movement, compact size, pleasant voice, and captivating round eyes. Developed by the French company SoftBank Robotics, Josie Pepper is equipped with Wi-Fi connectivity, enabling her to access cloud resources for processing and analyzing dialogues and integrating them with airport-related data. Through this mechanism, Josie Pepper continually learns from each interaction and provides personalized responses to individual queries. In the restaurant environment, Japan has embraced the use of high precision robots in kitchens, where they skillfully prepare sushi, chop vegetables, take orders, clean tables, and serve as waiters. This integration of robots in restaurant operations brings tangible benefits, with manufacturers claiming potential earnings boosts of around 20%. The fusion of advanced robotics and culinary expertise in Japan has resulted in enhanced efficiency and customer experiences, showcasing a remarkable blend of technology and gastronomy in the restaurant industry. Personal assistance and home automation. Robots are increasingly being developed for personal use and home automation. They can perform tasks like cleaning, cooking, home security, and personal assistance, making everyday life more convenient and efficient. A hybrid robot combines autonomous decision-making and independent reactions with the option for human control when needed. It incorporates AI software for autonomy and flexibility while still allowing human intervention. This design offers a versatile and adaptable robotic system that can operate both autonomously and under human supervision. Robotics and employment. There are some job displacement concerns. The fear of robots replacing human workers is a valid concern as robotics and automation continue to advance. However, it is crucial to address these concerns while also recognizing the potential impact on specific job sectors. Certain industries and job sectors are more likely to experience the impact of automation and robotics. Industries such as manufacturing, logistics, agriculture, and customer service are often cited due to the potential for automating repetitive and routine tasks. It is important to note that while automation may replace certain tasks, robotics can also create new opportunities and transform existing job roles. The likelihood is that robots will augment human workers rather than completely replacing them, allowing humans to focus on tasks that require creativity, problem solving, and emotional intelligence. Ethical considerations. The increasing use of robots raises concerns about privacy and data security. Responsible data collection and protection measures must be implemented to ensure consent and comply with privacy regulations. The autonomy of robots also poses ethical dilemmas, such as in self driving cars and healthcare settings, where decisions impacting safety and prioritization must align with social values. The use of robots in warfare raises accountability and civilian safety concerns. Collaboration among various stakeholders is crucial to address these ethical considerations and establish guidelines for responsible and ethical robotics development and deployment. Social impact. Robotics has the potential to enhance the quality of life for individuals with disabilities through assistive devices and improved accessibility. Assistive technologies like prosthetics and exoskeletons assist with mobility and independence. Robotics also improves accessibility in various environments. In terms of environmental sustainability, robotics contributes to the energy efficiency and waste reduction in manufacturing. Social acceptance and integration of robots require research in human robot interaction and addressing ethical considerations. The medical sector utilizes advanced technology, including robots, to enhance healthcare outcomes. Robots in healthcare can be categorized as medical robots and surgical robots. Medical robots are used in various applications, from administrative tasks to outpatient care, while surgical robots assist surgeons during operations. The development of robots in healthcare originated from industrial applications and evolved with the integration of cameras, sensors, and artificial intelligence. Medical robots play a crucial role in surgeries, clinical workflow, optimization logistics, management, and improving patient care and workplace safety. The field of medical robotics has witnessed significant advancements, expanding their capabilities in healthcare over the years. Robotic surgery is a highly advanced medical technology that assists surgeons in procedures using robotic systems. Surgeons control robotic arms with surgical tools from a console or viewing screen, allowing for precise and minimally invasive surgeries. The history of robotic surgery dates back to 1985, and the Da Vinci robot is widely used today. It has revolutionized various surgical specialties, including neurosurgery, heart and lung procedures, and ear and throat surgeries. Robotic technology is also integrated into urology, gynecology, and orthopedics. In addition to surgical applications, robots have transformed healthcare by optimizing supply delivery, facilitating disinfection processes, and enhancing patient engagement. During the COVID-19 pandemic, robots were used for patient interactions, and surveys showed positive acceptance of robotic assistance in healthcare settings. The ongoing advancements in robotics hold the potential to further improve patient care and operational efficiency. Robotic technology has had a significant impact on the healthcare industry, especially in surgery. Surgical robots who enable the minimal invasive techniques and precisions AV improved also the patient recovery. Surgical robots offer speed, accuracy, and the ability to perform complex operations with the assistance of AI and computer vision. The adoption of surgical robots is expected to increase as more players enter the market and gain regulatory approvals. These robots also play a role in surgeon education and training through AI and virtual reality simulations. Medical robots have applications beyond surgery and clinical training, medication dispensing, patient care, disinfection, and logistics. Specialized robots for rehabilitation, reception, nursing, and physical therapy are also emerging in the industry. They have improved dexterity. Robotic devices offer enhanced dexterity and precision compared to a surgeon's hand. This allows for better access to hard to reach areas within the body, enabling more precise surgical maneuvers. They have enhanced visualization. The use of a camera and magnification in robotic surgery provides surgeons with a clear and magnified view of a surgical site. This improves the accuracy and precision during the procedure. Reduce surgeon fatigue. Robotic assisted surgery can help reduce surgeon fatigue since the system translates the surgeon's hands movements into smaller, more precise movements of a robotic instruments. They eliminate the hand tremor. Surgeons may experience hand tremors during long surgeries, which can affect precision. Robotic assisted surgeries eliminates these issues as the robotic system can stabilize and filter out any unintended hand movements. Shorter hospital stays and faster recovery. Robotic assisted surgeries generally involve smaller incisions, leading to less trauma to the surrounding tissues. This can result in shorter hospital stays and faster recovery times for patients compared to traditional open surgery. And last, the reduced risk of infection. Robotic surgery's minimally invasive nature, along with smaller incision, can lower the risk of infection compared to the traditional surgery. These smaller incisions also mean smaller wound area that needs to heal. The growth of robots in the healthcare industry faces several barriers. High costs hinder their wide-scale adaptability, as training, operational expenses, and infrastructure upgrades contribute to the overall cost. Malfunctions of the electromechanical systems in robots can occur, posing risks during operations, despite technological advancements. Inadequate knowledge or skills from the human side can also pose challenges in utilizing medical robots effectively. Resistance to adopting new technologies is observed among patients and healthcare professionals, driven by concerns about the impact on traditional practices, trust issues, and resistance to changes. Overcoming this resistance and promoting acceptance and integration of medical robots into healthcare settings is a significant barrier to their widespread adoption. Robotic surgery is a minimally invasive surgical approach that utilizes robotic arms into small incisions to perform procedures with increased precision and flexibility compared to non-robotic instruments. The surgeon operates the robotic arms from a console, translating their movements into scaled movements of a robotic arm for precise control. This technique offers advantages such as improved range of motion, reduced scarring, and minimal blood loss, faster recovery for patients. Ongoing technological investments such as reconfigured arm designs and dual consoles for training continue to improve outcomes. Robotic surgery has shown feasibility, efficiency, and cost consideration in various procedures, including cardiothoracic, general orthopedic, urologic, and gynecologic surgeries. The increasing global demand for surgeries, driven by factors like cancer cases, laparoscopic advancements, and need for the cardiac and reconstructive procedures, poses challenges due to workflow shortages and insufficient access to surgical care. Robotic surgery has the potential to address these challenges by offering a minimally invasive option with improved outcomes, helping alleviate the burden on the healthcare system and ensuring timely surgeries for patients. Surgical robots. Surgeries can be highly traumatic experiences for individuals, involving risk and extended healing periods, particularly in the case of complex procedures. Additionally, performing surgeries that span 10 to 12 hours can be physically demanding for surgeons. However, a remarkable advancement in the field of medicine comes in the form of surgical robots, which offer significant assistance to doctors, enhancing surgical efficiency. These surgical robots are under the full control of skilled surgeons, providing them with enhanced precision and control during procedures. One notable example is the Da Vinci surgical system, which I mentioned earlier, which offers surgeons a high definition 3D view of a surgical area, coupled with robotic instruments capable of bending and rotating to a greater extent than the human hand. This level of precision ensures that operations are minimally invasive, enabling patients to recover more swiftly. The Da Vinci robotic system has successfully facilitated over 6 million surgeries worldwide, exhibiting fewer complications compared to traditional surgeries. The utilization of surgical robots not only enhances the capabilities of surgeons, but also contributes to improved patient outcomes and a faster recovery process. Robot assisted heart surgery. Robotic surgery, also called robot assisted surgery, allows doctors to perform many types of complex procedures with more precision and flexibility control than it is possible with conventional techniques. The robotic surgery is usually associated with minimally invasive surgery procedures performed through tiny incisions. It is also sometimes used in certain traditional open surgical procedures. The most widely used clinical robotic surgical system includes a camera arm and mechanical arms with surgical instruments attached to them. The surgeon controls the arms while seated at a computer console near the operating table. The console gives the surgeon a high-definition magnified view of a surgical site. The surgeon leads other team members who assist during the operation, which is also good to improve teaching. The major advantages of surgical robots. Medical robots offer numerous advantages in healthcare settings. One major advantage is their ability to enhance surgical procedure, ensuring smoother operations with minimal errors. Robotic assisted surgeries have a higher success rate compared to traditional procedures. The robots operate with precision and adhere to assigned timeframes, ensuring efficient and accurate performance. They provide proper monitoring services for patients, contributing to improved healthcare outcomes. Their flawless performance and adherence to protocols minimize the risk of infections. Moreover, robots optimize time utilization, maximizing efficiency in healthcare settings. They play a crucial role in caring for elderly and disabled individuals, engaging them in conversations to alleviate pain and boredom. The advantages of medical robots are numerous and significant. Another advantage of medical robots is their impact on patient care. By automating certain tasks, robots free up healthcare professionals to focus on more critical aspects of patient care. They provide consistent and reliable services, minimizing human errors and variability. Additionally, medical robots reduce the risk of infections and enhance patient safety. Robots excel at performing repetitive and mundane tasks, contributing to increased productivity and job satisfaction among the healthcare workforce. For the increased efficiency, robots can perform tasks more efficiently than humans. This is known, often as completing them at faster pace than a human being. Extended hours and repetitive cycles, the robots can work for long hours without getting fatigued, making them suitable for repetitive tasks that may be monotonous for a human being. The major disadvantages of medical robots. Despite their advantages, come with certain disadvantages that need to be considered. One notable drawback is the risk of mechanical failure, although rare, which can lead to injuries and damage to surrounding organs or nerves. Special attention is required in complex surgeries, such as neurological procedures, where even a small error can have severe consequences. Another disadvantage is the cost associated with medical robots. Implementing and maintaining robotic systems requires a substantial investment in equipment, training, and ongoing maintenance. Surgeons and healthcare professionals also need specialized training to operate medical robots effectively, which can be time consuming and resource intensive. Medical robots lack tactile feedback, which can be a limitation in certain procedures. Without a sense of touch, surgeons may not have the same level of tactile feedback as in the traditional surgeries, affecting tasks that heavily rely on touch. Despite these disadvantages, medical robots continue to advance and offer significant benefits to the healthcare industries. Proper training, maintenance, and ongoing evaluation of their performance can help mitigate the associated risks and maximize the advantages in improving patient care and treatment outcomes. Rehabilitation devices and assistive robotics. Robotics therapy or rehabilitation devices has emerged as one of the finest options for physical and occupational therapy as compared to conventional therapy. Rehabilitation devices are basically designed to optimize the neurological recovery of the affected person with repetitive motion. Robotic therapy provides necessary aid to the person with a condition or disease related to brain injury, central nervous system, a stroke, spinal cord injury, and other neurological disorders. Robots mimicking human body. The application of robotics is touching new heights which were unimaginable a few years back. Moving from electronic medical devices, now companies are working towards the development of artificial organs or implantable biorobotics organ that can mimic functions like the human organ. The artificial organs are engineered devices that can be easily integrable into the human body in case of damaged organs. At present, Most of these devices or biorobotics are in the early stage of development, expected to hit the market in the coming years. Prostheses and artificial organs. The shortage of donor organs is one of the major challenges in the healthcare system. To overcome this, some of the key companies are actively working in the development of artificial kidneys, artificial hearts, orthopedic implants, and several other organs. Prostheses and artificial organs aim to improve or restore the function of unhealthy or defective body organs. The demand for these therapeutical artificial organs market is gaining momentum as the R&D activity in the segment is growing. Simulators are in the use to provide training for practical and clinical skills to the healthcare professionals. Exoskeletons are remarkable mechanical and robotic devices designed to be worn by humans, granting them amplified strength and enabling them to accomplish tasks beyond their normal capabilities. While the notion of lifting a car with an exoskeleton remains a jest, their practical applications are truly impactful. One significant application of exoskeletons lies in the realm of surgery, particularly for surgeons who endure long hours during intricate procedures lasting 10 to 12 hours. These exoskeletons prove immensely valuable in mitigating fatigue, thereby enhancing concentration throughout the surgery. By alleviating physical strain, surgeons can maintain optimal performance and focus. Another noteworthy application of exoskeleton technology is in assisting individuals with spinal injuries or other physical impairments that limit their range of motion. These exoskeletons serve as aids in rehabilitation and can help partially paralyzed individuals regain mobility and learn how to walk again, as it can be seen in the video that I played on the slide. Telemedicine and remote care. Telemedical networks like InTouch Health and Doctor on Demand leverage technology to connect patients with healthcare professionals, regardless of their geographical location. These innovative platforms have transformed the way medical assistance is provided, empowering individuals to seek immediate medical attention and support when needed. Specialized robots have gained increased importance in healthcare facilities, including various purposes. They play crucial roles in disinfection and sanitization processes, utilizing techniques like UV sterilization to ensure a safe environment, especially during the COVID-19 pandemic. Telepresence robots enable remote communication between doctors and patients, enhancing access to healthcare services even in distant locations. Logistic robots, rehabilitation robots, receptionist robots, and nursing robots are on demand in healthcare facilities. Autonomous mobile robots have gained prominence in healthcare organizations due to their ability to address critical needs such as telepresence and the delivery of medication and medical supplies. These robots employ technology like light detection and ranging, visual computer systems, or mapping compatibilities to autonomously navigate to patients in examination or hospital rooms. This enables the doctors to engage in remote interactions and consultations, contributing to patient diagnosis and care. Additionally, AMRs can accompany doctors during hospital rounds when controlled by a remote specialist or another healthcare worker, facilitating on-screen consultations. Microbots. These remarkable robots could effortlessly navigate through your bloodstream, reaching any specific location within seconds. While such scenarios may seem confined to the realms of science fiction, they are rapidly becoming a reality. Scientists at the Max Planck Institute, among others, have been pioneering the development of microbots capable of traveling through the human body, delivering targeted medications or addressing specific ailments. They are incredibly small, with a thickness barely exceeding that of a human hair. They can traverse various bodily fluids, including blood, lymph nodes, and even the fluids within your eyes, offering tremendous potential for medical interventions. Despite the initial icky perception, their application holds significant promise for enhancing healthcare outcomes. Another noteworthy advancement is the origami robot, which, although not micro-sized, can be ingested within a capsule. Once inside the body, this robot can address numerous stomach-related issues, such as repairing the stomach lining or removing foreign materials. The versatility of these origami robots marks a significant step forward in the field of gastrointestinal medicine. As scientific research and technological advancements continue to progress, the emergence of these micro-robots and origami robots heralds a new era in healthcare. The potential for targeted treatments, minimally invasive interventions, and precise diagnostics could revolutionize medical practices, providing novel solutions to various health challenges. Nursing robots. Nursing is a profoundly rewarding profession, but it can also involve repetitive and mundane tasks. Nurses often find themselves performing routine duties for multiple patients day in and day out. However, there is a possibility that robots could one day assume these tasks, freeing up nurses to focus on responsibilities that necessitate human expertise, such as decision making, reactivity, and providing empathetic care to patients. One notable example of a nursing task that could be undertaken by a robot is venipuncture, the process of drawing blood for tests. It can be useful for both nurses and patients when multiple attempts are made to locate veins for blood collection. In such instances, a venipuncture robot could be invaluable. This robot utilizes infrared and ultrasonic imaging to generate a 3D image of a patient's blood vessels, simplifying the process of locating the correct veins and inserting the needle. By introducing automation in certain nursing tasks, nurses can devote more time and energy to providing compassionate and personalized care to patients. This shift in responsibilities allowed nurses to leverage their unique human capabilities, ultimately enhancing the overall quality of patient care. While there may be concerns and challenges in integrating robots into healthcare settings, their potential to alleviate the burden of monotonous tasks holds promise for the future of nursing practices. Future advancements. Augmented visualization and guidance image guided navigation, which can incorporate imaging from CT scans, ultrasound, or fluoroscopy, is becoming standard in robotic platforms because it provides direct vision to otherwise obscured anatomy. Surgeries that were once impossible because of a target location in the body are now feasible. Navigation is particularly helpful during minimally invasive procedures, which restrict the surgeon's vision of the operating area. Greater autonomy. Developments in sensor technology has also fueled advancements in complementing technology artificial intelligence. Some systems, such as the Titan Sport, harness automation to position cameras by tracking the surgeon's gaze or the position of their instruments. Minimally invasive surgeries. Robotic surgery has already made significant strides in enabling minimally invasive procedures. Future trends will focus on the further reducing the size of robotic instruments, allowing the surgeons to perform surgeries through smaller incisions. This will result in less trauma for the patients, faster recovery times, and reduced scarring. Now you can ask questions. Thank you.